Welcome, Algebra students, to Chapter 2, Section 2, where we will review adding real integers. Let's talk about the rules of addition. Go ahead and try this first sample quietly to yourself. -3 plus -4, and together it equals -7. Very good. So when we are adding integers that have the same sign, in this case they're both negative integers, we simply add their absolute values, right? As we were talking about yesterday. And then we give the sum the sign that the integers shared, right? Add the numbers with the same sign, add their absolute values, keep the sign. When we are adding integers that have different signs, here's a negative added to a positive, we have to do something different, don't we? So, pause the video and think about that for a second. Okay, so instead of adding their absolute values, we subtract, don't we? So the sum of -6 and 3 is -3. So in this case, because they have different signs, we subtract the lesser absolute value from the greater, right? And then the sum has the same sign as the addend with the greater absolute value. So 6 is further away from 0 than 3, right? -6 is further away from 0 than 3. So we give the sum a negative sign. Subtract the lesser absolute value from the greater absolute value and give it the sign of the greater absolute value. Kind of tricky to say, but you all are strong at this. Let's talk about the properties of addition now. The first property is the commutative. And as I've said before, commuting, you all did it to get to school today. Commuting means to move, right? We're talking about addition. You went from home to school. So this works the same with addition. The order that you're adding integers or numbers doesn't change the sum. This works for all numbers. So we can use a rule. A plus B equals, can you finish the rule? B plus A. So the order does not change the sum. This is a commutative property of addition. Associative property. Associations are groups. So you might have an association with Little League or with Pop Warner and with St. John's and maybe with, a dance team or a music school. So associations are how you're grouping yourself. It has to do with grouping, right? So with different groupings, different groupings don't change the sum. A way to look at this is with the rule. A plus B plus C can also be summed up as A plus B plus C, right? So we can add the first two integers together and then add that sum to the last, or we could add the last two numbers together and sum it together with the first. The grouping doesn't change the sum. Identity property of addition. What can I add to myself and maintain my identity? Well, the number that we can always add to a number and not change the value of that number is 0. A number plus 0 equals a number, right? So A plus 0 equals A. You can substitute any value for A, and this will be a true statement. The identity property of addition. Inverse property. What is the inverse of 3? Good, -3, right? So what happens when we are adding inverses? 3 plus -3. 3 plus -3, what do we get? 0, right. So the sum of a number and its opposite is 0. We can write this in the form of a rule. There's another example. You don't need to put that if you put this first one, right? But as in the form of a rule, we could say a plus, what's the inverse of a? Negative a. A plus negative a would equal 0. And there's your inverse property of addition. We have a final property called the closure property. And this property is used the least because it's such a common thing. When you add two numbers, let's say 1 plus 3, what do you get? 1 plus 3 equals 4, right? So you always get 4. In 25 years, if I say, what is 1 plus 3? Those students will say 4. So adding two real numbers gives a real sum every time. 5 plus 2 equals 7. It will always equal 7. Close the door on that one, right? So how could you write this as a rule? Using your letters again. And usually we begin with the beginning letters of the alphabet, right? So A plus B equals C, right? Good. So adding any two numbers will give you a real sum. Okay, you can put your pencils down and fold your hands together. Do not answer the question until I count you down. I'm going to show you an example and you are just to identify the property out loud. Hold your hands and please don't say anything until I have counted you down. I'm going to say 3, 2, 1, and then you may say it out loud. Ready? 3, 2, 1. Inverse property, right? Sometimes this is called the additive inverse because we're adding inverses. Another way to say inverse property of addition. It's a shorter way, isn't it? Additive inverse. Okay, don't say it. Wait. This is 3, 2, 1. Associative. Good. So this is kind of a sophisticated way to show the associative property because the negative 5, our leading term, remains the same, but 2 plus 3 have been grouped and become 5. And now all of a sudden over here, this is looking like additive inverse again, isn't it? But this entire statement is the associative property. Okay, I'm going to count you down. 3, 2, and 1. Commutative property. Good job. So we see that the addends have switched places. The sum is still equal. 3, 2, 1. Identity property. Y plus 0. Y maintains its identity when 0 is added. Okay? Excellent job. That's it for today. And you can continue on with this assignment and have a great day.